ஓகே சார். ஓகே சார்.
நான் மைக் போயிடுவாங்க. நான் மைக் போன பிறகு எனக்கு கேட்காது நீங்க பேசுறது. ஏதாவது மெசேஜா போடுறேன்.
கேக்குதுங்க சார். வாய்ஸ் கேக்குது சார்.
இல்ல இது கேட்கும். நான் மைக் போட்டோம்னா கிளியரா கேட்குங்க.
ஓகேங்க சார். ஓகேங்க சார்.
கேட்கலாம் எதுவுமே வராது. எனக்கு நீங்க பேசுறது கேட்காது. சப்போஸ் பேசுறது மட்டும் சாட் பண்ணுங்க. சாட்ல பண்ணுங்க. சரிங்களா?
ஓகே சார்.
ஓகே, தேங்க்யூ. Very good morning, friends. I really do not know how many of you are watching this video right now. Right. I hope I'm audible. I'll also check it for a minute. Acknowledgement is always better, right? Right, my friends. I think I'm audible. Okay, right. Right, my friends. See, last class, even I'm not very sure that what exactly is the topic we have taken it. Okay. But somewhere we talked about the wind, my friend. Last class we started with wind. Okay. There I talked about some of the very important types of wind, where we'll be having a wind and what exactly is the flow direction of this wind, both we have discussed, right? In that regard, my friend, the last class, right, we talked about planetary winds, my friend. Talked about planetary winds, right? And apart from planetary winds, we also talked about the regulators of the wind, right? So today what I'll do, right, I'll discuss about some of the very important local winds. Even I think that local winds also we have talked about, right? So the different local winds of the world and India we talked about, right? Okay. Okay, that's what my favorite memory says. If that is the case, right, the rest of the topic, the rest of the topic, we have a topic called as jet stream, and then we have a topic called as hydrological cycle, right? These topics will be discussed, right? My favorite memory says that last class we discussed about the surface winds, all the surface winds, like the planetary winds and the right, my friends, planetary winds and local winds, assuming that we have done it. Okay, as I said, we'll start with the concept called as jet stream. Jet stream. See, this jet stream is an upper air wind, my friend, right? Upper air wind. Okay. Sometimes you also call them as what? A geostrophic wind. Call them as an upper air wind, right? Or you call them as a geostrophic wind. What is geostrophic wind? See, this is a technical term. Any wind which flows parallel to isobars, we call them as what? Geostrophic wind. All right. Why it is flowing parallel, that much detail is not needed for general studies, right? Geography as such. Okay. Right. So this upper air wind, what we have, which flows at tropopause level, you call them as what? Jet stream, my friend. All these wind, as I said, it flow at tropopause level. What is this tropopause level, my friend? The level of troposphere, you call it what? Tropopause. Okay, it flows at tropopause level. Now, my dear friends, now comes the question: how many jet streams are there? Right. Normally, if you ask me, the jet streams are majorly two names, my friend. You have jet stream both in northern and southern hemisphere. Both the places you have jet stream. Okay. So, approximately bring this jet streams here. in both the hemisphere, my friend, in both the hemisphere, we have this jet stream, right? So predominantly we have two repetitive names. Okay, what are the names if you ask me, right, which flows at tropopause level, right? If you're there in northern hemisphere or southern hemisphere, whatever it is. Number one, you call them as what? Subtropical jet. You call them as what? Subtropical jet stream. Or simply I call them as what? Subtropical jet. Call them as what? Polar jet, my friend. Polar jet. But what happens during winters? This polar jet gets bifurcated in two. Not during every time, my friend. During winter, it gets bifurcated. So during winters, it becomes, right, polar night jet. And it becomes polar frontal jet, my friend. It becomes polar frontal jet. Okay. So every time it doesn't happen, only during winters it gets bifurcated. During winters. Right. Rest of the time, what happens? Both these jet streams will be combining together and will be flowing as what? One continuous jet stream. Right. So I have jet streams. By name, sometimes it becomes three. Now the biggest question. Right. Is this jet stream is there also there in southern hemisphere or not? See, if you are writing geography as an optional subject, then you can still debate, you can talk about different school of thoughts which talks about this. But when I talk about general studies, my friend, you have to go for a common fact. Okay? You should not go about a specialized fact, you have to go for a common fact. The common fact says jet stream is there in both the hemispheres. Am I right? See, for example, if I was just going for a debate as such, right? If I just say, for example, assuming that I'm going for a specialized fact, even see, there is another image. Same Google, I just typed it as what? Jet stream. One image is showing as though, right, this jet stream. What exactly you're about to see now, it is there only in another hemisphere. So many friends, we'll take a conclusion that when it comes to jet stream, assume that jet stream is there in both the hemispheres. But whatever be the case, only when the UPSC keys finally out, my friend, we can take a decision on it. Okay, whatever be the case. Right. Now, what is a jet stream? We have an idea. Now comes the question, why it is called as a jet stream? See, this wind is called as a jet stream because of its high velocity, my friend. Right? So somewhere you can take a very small definition that is given by WM. World Meteorological Organization has given a definition of it, my friend. It has given a definition. So somewhere you can mark the definition. What exactly is this? Jet stream, you can take it as a definition. Somewhere you can write it. The fast moving centers of an upper air geostrophic wind. I repeat, the fast moving centers of an upper air geostrophic wind, which has a velocity of more than 200 kilometers per hour. More than 200 kilometers per hour is called as jet stream. So what is an idea? Here, the velocity of the wind is high, my friend. Okay. Now comes another question. Why exactly the velocity of the wind is high? Why? The reason is very simple. It is all because of what? Frictional drag. Okay. Friction is very minimum there. That's the reason why velocity is very, very high, my friend. So, okay. Right. Now, every jet stream has few things in commonality, my friend. If you ask me, what exactly is the direction in which this jet stream flows? Every jet stream flows from what? West to east. See, I am talking about permanent jet stream. Okay. So every jet stream, permanent jet stream, they flow from what? West to east. If you ask me why, of course I understand it is all because of what Coriolis effectivity. Technically they say, when pressure gradient force and Coriolis force acts in opposite direction, this will be resulting in what? Geostrophic in nature. But my dear friends, detail, that much detail is not at all needed in geography. Here, GS geography, it is not needed. See, one thing always I used to say, when you are preparing for this subject for competitive examination, humble request, do not get into the details of the subject, not needed. Am I right? What is needed for the examination, kindly take it and rest of it you leave it. In that regard, my friend, why, if you ask me, why exactly this wind moves from west to easterly in fashion, or west to east in fashion, if you ask me, my friend, either you call them as a Coriolis effectivity, all because of what? Coriolis effect, or simply you say, as a layman, you say it is all because of what? Rotation of Earth, my friend. Rotation of Earth. Okay. So all this, right, permanent jet stream, they flow from west to east, right, west to east. As the case, it encircles the entire Earth. So encircles the entire Earth, right? That's the reason sometimes you also call them as a garland system. You call them as a garland system, right? Right. So what is a jet stream? We have taken the definition, right? And approximately, I also show you at what level this jet stream is flowing, my friend. You ask me at what level it flows, right? Right. Approximately subtropical region, you know, which latitude you call them as a subtropical region. Okay. So one more image I'm just copying for you, right? It's pasting the same. Where exactly you have these winds which is flowing, if you ask me? My dear friend, one, subtropical region. Okay. Somewhere around 30° north and south, we have the subtropical jet which is flowing. And 60° north and south, where exactly we have this polar jet which is flowing. Okay. So approximately there, we have this jet stream which is flowing. And my dear friends, when I talk about this jet stream, these jet streams do not flow exactly from west to east. These are upper air wind. They are not flowing at the surface. These winds, they flow in, say, for example, in a wavy pattern. This is how this jet stream flows. Right? They do not exactly flows in east to western direction. These winds, they move in a wavy pattern. This wavy pattern is very popularly called as Rossby waves. It's called as Rossby waves. Okay. You ask me, what is this Rossby wave? Somewhere a very small one-line definition you can take it. The latitudinal and altitudinal oscillation of jet stream. Latitudinal and altitudinal oscillation of jet stream is called as Rossby waves. It's called as Rossby waves. Right. Why it should oscillate, if you ask me, again the reason is very simple. It is all because of what? Land and water divide, my friend. Okay. So land and water divide. You know one thing, right? Whenever land and water transition takes place, isobars or isotherms normally registers a kind of a bed, right? So I understand that, right? The jet stream is no exception to it, right? So what is a jet stream? We had an idea. Where all we have the jet stream, that also came, right? And what are the different names of jet stream that also we have taken? And somewhere I said, both the hemisphere you have what? Jet stream, my friend. Both the hemisphere you have jet stream. Okay. And I told you very importantly, this jet stream flows from west to east. Why? What is the reason for it? All because of what? Coriolis force or rotation. Correct? Right. Now here, what is the role played by jet stream in inducing the climate of a place? Very little, my friend. Very little. See, monsoon as a mechanism, I have a wind called as tropical easterly jet. Right? Every jet stream is a westerly jet. But when I talk about tropical easterly jet, that comes from the east, right? Because that's a temporary jet stream. Okay. All permanent jet streams are westerly. So tropical easterly jet triggers the mechanism called as southwest monsoon. I understand. All right. But otherwise, my friend, jet stream plays a very less prominent role in determining what the climate of a particular place. Okay. It plays a very less role or less prominent role. Right. But however, there is one jet stream induced precipitation that happens in India. If you ask me what exactly is that precipitation, you call them as, I guess that's very popularly you call them what? Western disturbance. You call them as what? Western disturbance. So what is this western disturbance? Simple. As a layman, if you want to understand what is this western disturbance, I would say the winter precipitation in India. The winter precipitation in India is very popularly called as western disturbance. Now comes another question. Is it entire India experience this western disturbance? No. Only that part of India which experienced winter experience what? Western disturbance. So which part of India experience winters? Simple, my friend. Normally you say it is northwestern part of India. So we are there in northwestern part of India, my friend. Right? The northwestern part of India is the one which experiences what? Western disturbance. And the easy understanding will not complicate it, right? Not at all complicated. What we'll do, approximately showing the place where you experience western disturbance, my dear friend. I can divide India into 4 quadrants or 4 quarters, right? How? North and South India can be divided with what? Tropic of Cancer. Okay. You can divide it with what? Tropic of Cancer, approximately. Right. East and west of India can be divided with what? Right. The central meridian of India. You can divide it with what? Central meridian of India. See, this is what is 82.5 degree east longitude, and another is what? 23.5 degree north latitude. So somewhere I'm just dividing India into 4 quadrants. Approximately, if you ask me, which part of India experience winter, right? It is the northwestern part of India that experience what? Winter. Right? If that is the case, right? This is the place which is also going to experience what? Winter precipitation. Winter precipitation. Right. And my dear friends, simple, right? What I have just shown is approximately the region in India which experience winter. See, marginally I can have the extension. Slightly coming into Bihar. Right? You can also remove the places from Gujarat. Right. This is the place in India which experience what? Winters. And my dear friends, if that is the case, I understand. If I just talk about Rabi, you have heard about this Rabi crops, right? What is this Rabi crops? All this winter crops, the crops which is cultivated during winter, you call them as what? Rabi crop. So which region in India you will go for Rabi crop? Simple. That place where you experience what? Winters. Again, I am giving you a clue. Am I right? See, geography, never read it as a fact. Connect things. And one more thing, every day you see geography, am I right? So connecting things should not be a problem at all. Am I right? Right, my friends. So approximately I have just shown you that where exactly we experience this winter precipitation in India. Right. So to be very precise, Jammu and Kashmir, Ladakh, Himachal Pradesh, Uttarakhand, Punjab, Haryana, Delhi, right? Near complete Rajasthan, right? Complete, right? Or I would say the majority part of Madhya Pradesh and the western part of Uttar Pradesh. These are the places in India which experience what? Winters. Okay. Right. So what is winter precipitation? We had an idea, western disturbance. Now, the name says western disturbance. Now comes the question. Somewhere I said, western disturbance is nothing but what? Winter precipitation in India. Now comes the question, what is that mechanism which brings this wind to India? Right? The carrier of this moisture, my friend, right? It is resulted by what? Subtropical jet, my friend, right? This precipitation is resulted because of what? Subtropical jet. Now finally, like if you ask me, okay, everything is fine. Now you tell me from where exactly this moisture is coming from. My dear friend, this moisture actually comes from what? Mediterranean Sea, my friend. So I talk about this moisture, how this moisture comes from, if you ask me, because this moisture comes from Mediterranean Sea. Where I'll zoom it so you can see slightly better. Okay. So this moisture, my friend, comes from Mediterranean Sea. Okay. So it gets evaporated, it becomes part of the subtropical jet, and because of this Rossby waves, I understand it will go for oscillation. Right? Latitudinal oscillation will be there. So from higher latitudes, it collects the moisture and brings the moisture and delivers in India, correct? And again, it will go for an oscillation. The easternmost region where this moisture is delivered is India, my friend. Okay. So what is western disturbance? Somewhere we have an idea. Okay, we have an idea. Okay. So to be very simple, I said winter precipitation in India, we call them as what? Western disturbance. Nothing else. Okay. What is that wind which brings western disturbance in India? It is subtropical jet. That's it, my friend. Right. So in simplicity, what is jet stream? We had an idea. Only the basic facts we have taken. See, jet stream itself, you can do a research, and research can sit on jet stream for 5 years. The only thing is that somewhere I should be satisfied with the limited facts, what it is needed for the examination, and I can go to the next topic. Because I always believe that if at all if you can study, not teaching geography, but if you can study geography, entire all, right, the physical geography of the world, the physical geography of India, human geography of the world, and human geography of India, everything put together, if you can complete it into 60 to 70 hours, right, that is the ideal time for preparation of what geography. So that limited facts should be fine enough, right? So what we have done, right, all these, right, wind we have completed. Last class, we talked about planetary winds, we talked about local winds, right? And assuming that we would have also talked about, right, the local winds of India, right? Everything is right. Now, we also talked about, see, monsoon, I have just reserved it for the later classes, but somewhere, understanding upper argument called as jet stream also we have taken, we have completed. Now, entire wind distributor. See, if you remember, my friend, earlier classes we said, right? See, insolation is the one which results in atmospheric temperature, and temperature is the one which in turn results in pressure system, and pressure system is the one which instigates the movement called as wind, and wind is the carrier of moisture and finally delivers the moisture at a particular place and results in what? The climate ultimate. So we have completed insolation, temperature, pressure and wind, barring the exception of what? Monsoon. We have completed wind, my friend. So what next is only climate. So in between what we'll do, some of the miscellaneous topics what we have left in climatology we'll see, my friend. So one such miscellaneous topic, what we are left in between, very popularly, we call them as what? Hydrological cycle. We call them as what? Hydrological cycle. Now see, what is the hydrological cycle? That's the biggest question. What is the hydrological cycle? Name itself says, right? Somewhere, a single line definition you can write it. The cycle of water in atmosphere. I repeat, the cycle of water in atmosphere is called as hydrological cycle. All right? Right. Right. Now, what happens here? See, for example, as I said it is cycle of water in atmosphere. So simple, my friend. See, somewhere, correct? You have a surface water, my friend. Okay? Assume that you have a surface water. You have a surface water. Okay. Now, this surface water has to go for a cycle. Am I right? It has to go for a cycle. In some means, my friend, by some means, the surface water, right, has to get evaporated, and the surface water has to become what? Water vapor. Correct? It has to become water vapor, my friend. What is water vapor? See, water in the form of gas, you call them as what? Water vapor. Technically, you call them as what? Humidity vapor. Right? Now, if you ask me, how exactly this water becomes water vapor, if you ask me, my friend, right? It is by the process, what you call them as what? Evaporation, my friend, majorly. It is not only evaporation, but majorly it is evaporation. Evaporation is the process which largely makes the surface water into what? Right, it is water vapor, my friend. Right, it makes it as a water vapor. Very fine, right? Right, my friend. So what is evaporation? Right. Now assume that it has become water vapor. Now by some means, my friend, this water vapor should go for a process called as condensation, and eventually it should become what? Cloud. Right. It should become cloud. Some means it has to become cloud. Okay. Now the process by which this water vapor becomes cloud, if you ask me, this process very popularly we call them as what? Condensation, my friend. We call this process as what? Condensation. Right. We call them as what? Condensation, right? Water vapor becoming cloud. This process we call them as what? Condensation. Assume that cloud is also formed. See, cloud is not actually the aggregated means. People think that cloud is water vapor. No, cloud is not water vapor. Cloud is a condensed form of water or water vapor. Am I right? So what is condensation? Water vapor either becoming water or ice crystals. Right. So that's what I call them as cloud. So WMO's definition says cloud is an aggregate of tiny ice crystals and minute water droplets. That's what they call this what? Cloud vapor. Okay. So cloud constitutes both water and water vapor. Sorry, excuse me. Water droplets and ice crystals. Right. So once the cloud is formed, what happens, my friend? Ultimately, sometimes the condensed material with the effect of gravity will start falling, my friend. The condensed material that is falling with the effect of gravity, right? Very popularly, we call them as what? Precipitation. We call them as what? Precipitation. Okay. Precipitation is the last cycle of hydrological cycle. Right. The last cycle, we call them as what? Precipitation. So, my dear friends, now what we are going to talk about, we are going to talk about the cycle that exists between evaporation, condensation, and precipitation. So what is hydrological cycle? Somewhere we have defined it. Now, individually, component-wise, every compartment of the cycle we have to discuss individually. Now, the definition further you can elongate it or elaborate it. Somewhere I said, the cycle of water and atmosphere is called as hydrological cycle. Somewhere you can write. It is the cycle. It is the cycle that exists between evaporation, condensation, and precipitation. It is the cycle that exists between evaporation, condensation, and precipitation. Right, my friends. So what is hydrological cycle? We have an idea. The only thing is that one by one we have to take it. So first I will start with water vapor present in atmosphere. So water vapor present in atmosphere, sometimes, right, you call them as what? Atmospheric moisture, or you call them as what? Humidity vapor. Sometimes you call them as what? Humidity. See, there is one small difference that exists between atmospheric moisture and humidity. What is the difference? I'll tell you. See, for example, when I talk about the water vapor present in entire atmosphere, I call them as what? Atmospheric moisture. But the air, or actually the water vapor present in specified air column, I call them as what? Humidity. So moisture or humidity is nothing but what? Water vapor, right? Present in atmosphere, my friend. All right. So somewhere on single line definition you can write what is atmospheric moisture or humidity. Write it. The amount of water vapor present in atmosphere is called as atmospheric moisture. It's called as atmospheric moisture. Whereas water vapor present in a specified air column, water vapor present in a specified air column is called as humidity. It's called as humidity. Right. What is atmospheric moisture? What is humidity? We have an idea. Right, my friend. Now, if you ask me what exactly is the source, right, source of this atmospheric moisture, how exactly this atmospheric moisture is added to atmosphere, if you ask me, plenty of sources. Either I should say it is source or it is process, my friend. It is the process by which this water vapor is added to atmosphere, if you ask me, plenty of process of it. But if you ask me which is the most commonest factor or process, it is evaporation, my friend. Evaporation. Apart from evaporation, what else you have if you ask me? See, for example, what can add water vapor to atmosphere? Transpiration. Right? Transpiration. What is transpiration? The water vapor that is added from the leaf of the plant, you call them as what? Transpiration. Right? So what is evaporation? What is transpiration? We have. That's the reason normally we say, whenever a wind crosses a water body, it can collect moisture. Or when the wind crosses a forested region, right? It crosses a forested region, it can collect moisture. Right. So it can deliver. That's the reason normally we say forest is very important for aiding what? Precipitation. Because the water vapor will be collected from forest. How? Transpiration. Whenever it is almost, say, for example, primary production as an activity is taking place, right? Photosynthesis was taking place. This means whenever it takes place, water vapor is eventually released into the atmosphere. Apart from evaporation and transpiration, my friend, even respiration, very small amount, but still respiration can also add water vapor to the, right? Even you have a process called as sublimation. What is sublimation? See, a solid will become liquid and liquid will become gas. And temperature increases or vapor pressure changes. Okay. So what happens when I talk about sublimation? Sublimation is the process where solid directly become gas. From glaciers, directly water vapor will be added to the atmosphere. It will not become water and water vapor. Directly it becomes water vapor. Right? Extraordinarily situated. That process you call them as what? Sublimation. See, these are some of the commonest process which adds atmospheric moisture. And somewhere if you ask me, my friend, I will tell you, even volcanic activity can also result in what? Can also add moisture. See, for example, today you have oceans, right? But if you ask me from where exactly this ocean came from, volcanic activity, my friend. You would have heard about the process called as degassing. Correct. Even today we have the process of degassing taking place. Correct. When I talk about any volcanic activity, the commonest gas that is emitted during any volcanic activity is what? Water vapor. Right. So some of the very important process, right, that adds atmospheric humidity is this, right? The process what I said, my friend, evaporation, transpiration, respiration, sublimation, volcanic activity, and my dear friend, the very important fact, according to me, if you ask me, I would say etc. Okay. Sometimes you should not see it in a sarcastical manner, right? But sarcastic means? Most of the time, whenever I bring this word called as, right, etc., it is seen as a sarcastic way of including facts, but it is more practical, let me tell you. Because what happens most of the time, the fact what you study from the books and the question that is asked in examination, they don't match exactly with each other. That's the reason normally we say, my friend, common sense is very important in answering the questions. It is not like the examinations of your, right, say for example, the class examinations where each and every line you produce from the books. That itself is, I call them as an utmost stupidity. Right? By adding things without understanding what exactly is written there, right? Rote memorization, stupidity. But whatever be the case, my friend, right? Let me tell you, you are gathering any books will give you the basic information, and always you should move beyond the books for added information, value addition requirements. Okay. So that's the reason I'm just giving you provisionally. I'm just giving you this word called as what, etc. Okay. Right. So, what is this atmospheric humidity? We have said. What are the different sources we have? Process that adds moisture, that also we have seen. Right. Now, my dear friends, comes the question. Measure of moisture, measure of humidity. How do you measure humidity? So when I talk about measure of humidity, right, there are different ways, but let me bring you, right, the three very important ways of measuring humidity, my friend. What are they? Right, number one, my friend. Number one. Number one, it is absolute humidity. You call them as what? Absolute humidity. And number two, you call them as what? Specific humidity. And number three, we call them as what? Relative humidity. We call them as what? Relative humidity. See, what is very important here, what is commonest way of measuring the same is this measure called as what? Relative humidity. The only thing is that we'll understand what is what. Everything we'll understand, right? What do you mean by absolute humidity? What do you mean by specific humidity? And what do you mean by relative humidity? We'll understand. Relative humidity is the best way of measuring what? Humidity. Right? Right, my friend. So only thing is that I should understand what? Absolute humidity, the meaning. What is the meaning of this absolute humidity? See, absolute humidity is not climatologically sound, my friend. I talk about absolute humidity. Okay, what is this absolute humidity? Okay, see, what is humidity? Water vapor present in an air column or air mass. Air column is volume, air mass, as I said, it is mass. Now here, my friend, what is absolute humidity if you ask me, right? Amount of water vapor, somewhere you can write it. What is absolute humidity? Let me indicate it. The amount of water vapor measured in grams present, measured in grams present in 1 meter cube of an air column. In 1 meter cube of an air column. It's called as absolute humidity. I repeat again, I said, the amount of water vapor, my dear friends, humidity itself means what? I talk about humidity. In general, if you ask me what is humidity, whatever be the way of measuring it, humidity is nothing but what? The amount of water vapor present, right? To some air mass, in some air mass. Okay. Some air mass, that's what you call them as what? Humidity. Whatever be the way you measure it, you define it. Humidity is what? Amount of water vapor present in some air mass. Okay. So what is this absolute humidity? The amount of water vapor measured in grams, right, present in 1 meter cube of an air column. That is what you call them as what? Absolute humidity. Simple, right? 1 meter cube. Somewhere if I am just taking 1 meter cube, my friend. Right? Somewhere. Assume that I am just taking some meter cube, 1 meter cube of an air column. Right. So in 1 meter cube of an air column, right. How much of water vapor is present? Say for example, right. I'll bring it with right. The blue dots. Assume that this is water vapor present. Okay, what water vapor is present in? Right. This 1 meter cube of an air column. That's the idea. Right. So 1 meter, and 1 meter. Okay. So amount of water vapor present in 1 meter cube of an air column. That's what you call. That's what absolute. But what is the problem of absolute humidity? I'll tell you, my friend. This absolute humidity value will change with the changing time. It will change with the changing time. Say, for example, it is highly fluctuating in days. But you know, see, all of a sudden, right? The sun is rising. What happens? Temperature will increase. If temperature increases, what happens is air mass will expand. Right? Water vapor is not going to change. Air mass will expand with rising sun. Hence, declining sun, air mass will contract. Right? So what happens every day, every hour, the temperature of a place changes. And this, say for example, the expansion and contraction of air mass also changes. What happens, my friend? Absolute humidity, the biggest problem of absolute humidity, it readily fluctuates with changing temperature. It readily fluctuates with the changing temperature, my friend. Right now, what is absolute humidity? We have an idea. Okay, it's not having that much. Say, for example, climatological role or value. What is slightly better than absolute humidity is specific humidity. Only small differences there. Specific humidity. What is the specific humidity, if you ask me, my friend? See, same amount of water vapor measured in grams, but present in 1 kilogram of air. Right? My dear friends, as I said, water vapor, right? Let me write it as, right? Water vapor measured in grams, am I right? Present per 1 kilogram of an air column, kg of air mass. Right, that's what you call them as what? Specific humidity. Somewhere if you want to write a definition, small definition, kindly write it. Kindly write it. Specific humidity. What is specific humidity? You can write it. The amount of water vapor measured in grams present in 1 kilogram of an air column. So a column you can write it as what? Air mass. Present in 1 kilogram of an air mass. So that's what you call them as what? Specific humidity. See, specific humidity, what is the advantage of specific humidity? It do not fluctuate with temperature. Pause. Even if it expands, the mass is going to remain the same. Even if it is going to contract, the mass is going to remain the same. Right? So along with the water vapor, it expands. Along with the water vapor, it contracts. And as simple as this. Correct. So somewhere I understand, it do not readily fluctuate like that of what? Absolute humidity. Right? But specific humidity will give you the driest and wettest air mass. In that regard, if you ask me, which is the driest air mass. This driest air mass is identified with somewhere around 0.2 grams of water vapor present in 1 kilogram of an air column. Driest air mass. You can ask me where exactly this air mass is located. It is located in what? Polar regions. Polar regions. Driest air mass. Right. I have something called as a CT or CP. Okay, later I'll tell you what is a CP. CP means continental polar. The driest air mass, what? CP, continental. On the other hand, if you ask me which is the wettest air mass, my friend, of course you know the region. Approximately, if I was giving you the value taken from all the books, my friend, anywhere between 18 to 40 grams of water vapor present in 1 kilogram of an air column. Where, my dear friends, mostly tropical rainforest or equatorial rainforest, my friend. Equatorial rainforest. Tropical rainforest, you can add it. I'm not going to deny it. Okay. So this is the place where I'll be having the wettest air mass. And my dear friends, this wettest air mass, sometimes you represent it as what? Maritime tropical air mass. MT. Call them as what? MT. CPMT. Okay. Right. So what is absolute humidity and what is specific humidity? Approximately. Right. What is the only difference? Absolute humidity, the same thing in 1 meter cube of an air column. Specific humidity is for mass, 1 kilogram. Correct? Absolute humidity readily changes with the changing temperature. Specific humidity is not the case. Right? But what is the problem of specific humidity? Specific humidity will not tell you whether it is going to precipitate or not. So in that order, my friend, if you ask me, what is the best way of measuring this thing? Right? We call them as what? The relative humidity. We call them as what? Relative humidity, my friend. So, when talk about relative humidity, has a very important climatological role, my friend. So, what is the relative humidity? See, relative humidity is a ratio. Ratio between what? Say, for example, the amount of water vapor present in an air mass or air column, right? Water vapor, right, present in an air column to its carrying capacity, my friend. Right? Carrying capacity. Carrying capacity. What is this carrying capacity? The maximum water vapor what an air mass can carry, we call them as what? Carrying capacity. And this carrying capacity changes at the given temperature. Right? At every temperature, this carrying capacity changes. And this relative humidity is expressed in percentage. That's the reason we multiply it by what? 100. Formula is not needed. The only thing is that I'm just telling you it is a ratio. See, for example, you're writing a test mark. Maximum mark is 100. That's what the carrying capacity is all about. Right? Assume that you are also getting 100. That means saturated. Am I right? So somewhere you cannot go beyond 100 normally. Am I right? But this carrying capacity will change with the changing temperature. Right? This carrying capacity can increase or the carrying capacity can decrease. That increases and decreases with temperature. Okay. So carrying capacity increases with temperature. Okay. Right. So somewhere you can write a definition. What is this relative humidity? Relative humidity is the ratio. Relative humidity is the ratio between the amount of water vapor present in an air mass to its carrying capacity at a given temperature. One more sentence you can write it. You can say, it is expressed in percentage. It is expressed in percentage. Right. Fine, my friend. Right? Somewhere I understand what is the relative humidity, we have an idea. My dear friends, relative humidity is the one which differentiates between saturated and unsaturated air mass. See, what is a saturated air mass, if you ask me? When the relative humidity is 100%, then you call them as what? Saturated air mass. Only the saturated air mass, right, will go for condensation. If this air mass is not saturated, it will not go for condensation. Very, very important as a concept. Only saturated. Now comes the question, how do you increase relative humidity? Only if you increase the relative humidity, it can become what? Saturation. It can become what? Saturation. Now, what are the different ways you can increase this saturation, right? Or this increase the relative humidity, if you ask me? Number one, my friend, you can increase the supply of water vapor. But there is a restriction. On what occasion you can increase the supply of water vapor? What occasion? And you can increase it only if you have the source of water. Either the wind should be crossing a water body, oceans, sea, large lake, right, or a forest, transpiration. But otherwise, this is very restricted. But what is very, very common is decreasing the carrying capacity. Right, very common, right? How exactly relative humidity is increased? It is increased by decreasing the carrying capacity. Very simple, right? Either you increase the numerator or decrease the denominator. Both ways, this relative humidity is going to increase. Right? Now, my dear friends, now comes the final question. Right? Assuming that I was asking you this question and you yourself try to answer this question. How exactly the carrying capacity can be reduced? Simple. Carrying capacity can be reduced by reducing temperature. How can you reduce temperature? Again, very simple, by increasing the height. Right? That works on the principle of what? Normal lapse rate. Normal lapse rate. You increase the height, temperature decreases. My dear friend, the reason always I say how condensation is facilitated. Air mass should rise. That is very, very important. Air mass is not rising, condensation will not take. When air mass is rising, height is increased, temperature decreases. Temperature decreases, carrying capacity decreases. Carrying capacity decreases, relative humidity becomes 100%. When it becomes saturated, it goes for cloud formation. Cloud formation will be resulting in what? Protection. See the beauty. This is what I call them about linking chain. Correct? Right, my friend. Okay. So what is relative humidity? How exactly you can increase or decrease relative humidity, or what happens in atmosphere in general? Right? I'll give you one practical example, crude example, my friend. Right? Very crude example. How the practical way of reducing this carrying capacity and increasing relative humidity. See, for example, some air mass at some temperature, I'm just taking some temperature. Assume that at this temperature, right, this air mass is having some water vapor content. Okay. And at a temperature, I understand carrying capacity also changes. Carrying capacity changes. Right? Depending upon the water vapor and carrying capacity, always you can, right, bring out this relative humidity. And I can also determine the nature of this air mass. So, right, my friends. So, somewhere some crude example I am just giving you. Assume that the temperature given is somewhere around 20 degrees centigrade. So this air mass is somewhere having 10 units, 10 units of water vapor. But this carrying capacity is somewhere around 20 units, my friend. Okay. You calculated 10 by 20, right? It is somewhere around 2.5. Converted to percentage, it is 50%. So the relative humidity is somewhere around 50%. By the time I say relative humidity is 50%, you know the nature of this air mass. This air mass is what? Unsaturated air mass. Right? You call them as what? Unsaturated air mass. Okay, fine. Now, how do you make this unsaturated air mass a saturated air mass? How do you increase the relative humidity? right? You have to decrease the carrying capacity. How do you decrease the carrying capacity? Right, by increasing the height or reduction in water temperature. Right. Assume that I'm increasing the height. By increasing the height, I'm reducing the temperature. Right. Very crude example I've just given you. Right. Let the water vapor be what? 10 units. Now the carrying capacity I've reduced. Assuming it is 10 units, my friend. Then now what happens? All of a sudden, it becomes what? 100%. Correct. This 100% we call them as what? Saturated air mass. Right? Unsaturated air mass is what? Relative humidity less than 100%. Right, my friends. Now we have a biggest question. What will happen if you further increase the height? See, when I say further increasing the height, I'm giving you a practical example. But last class we talked about. Assume you have a mountain and you have an air mass which is rising along the slopes of the mountain. Correct. Now, as and when the air mass rises, temperature gets reduced, carrying capacity gets reduced. Carrying capacity gets reduced, relative humidity increases. That's the reason. Right? Cloud is formed and results in what? Precipitation. So, my dear friend, so whenever I just talk about increasing the height, it's a natural process. Using some slopes of the mountain, using a front, right, or on its own, my friend, or on its own, it can, right, increase the height. Okay. Right, my friends. Right. So, I'm just talking about a situation where one unsaturated air mass is eventually becoming what? Saturated air mass. Okay. Right. By reducing the temperature, somewhere I said this one unsaturated air mass becomes what? Saturated air mass. Now comes the biggest question. What will happen if this height is further increased and the temperature is further reduced? Say, for example, I'm just giving you an example. Assume that this air mass is further rising and it is almost there, for example, right? Reducing its temperature further, right? It becomes 8 degrees centigrade. Am I right? And the water vapor content is same. Am I right? Carrying capacity now gets reduced to 8 units. Am I right? Working, for example, more than its carrying capacity. Now, this is a situation where the relative humidity is more than 100%. It's more than 100%. So the place where exactly you have the relative humidity more than 100%, correct? Call them as We call them as what? Supersaturated air mass, my friend. Right? So what is saturated air mass? What is unsaturated air mass? And what is supersaturated air mass? Right? We have an idea. Right? Right, my friends. So what is what approximately we have an idea, and let me tell you which air mass will go for condensation. Okay. Only the last two category, my friend. Only an air mass, right, which is either saturated or supersaturated air mass, right, it goes for condensation. Right. Only this air mass may result in condensation. Okay, right. Right, my friends. So everything is fine. So what is atmospheric moisture or humidity? Approximately we had an idea. Right. In detail we have discussed. Right. What is the process? How exactly it is added to the atmosphere? What are the different way of measuring it? What is absolute humidity? What do you mean by specific humidity? And what do you mean by relative humidity? Everything we have taken at my friend. Okay, right. Now we have to go for the second compartment of the cycle. Now, what is the second compartment of the cycle? Right? Water vapor evaporation we have completed. Second compartment of the cycle is what? Condensation. All right. Second compartment, as you know, you call them as what? Condensation. Call them as what? Condensation, my friend. Now comes the question, what do you mean by condensation? See, condensation is the process by which, right, a gas, right, either becomes what? Liquid, or it becomes what? Solid, my friend. Right, a gas either becomes liquid, or it becomes solid. The process is what? Condensation. Now, my friend, what exactly is the gas here? Gas here is nothing but what? Water vapor. So this is the process by which water vapor, right, either becomes, right, the water droplets, right, or it becomes ice crystals, right? Either it becomes water droplets or simply it becomes what? Ice crystals. Ice crystal is nothing but what? Solid. Process you call them as what? Condensation. Alright? Either gas becoming liquid or solid, or this water vapor becoming what? Water droplets or ice crystals, you call them as condensation. Right? So very small definition you can write it by that. Very small definition you can write. The process by which water vapor either becomes water droplets, or ice crystals, is called as condensation. It's called as condensation. Everything is fine, my friend. Now comes the question, okay, everything is fine. Water vapor is going to become water droplet, or it is going to be ice crystals. It should either become water or it should become ice. Correct? Or ice cubes, ice crystals, as we say. Correct? Now comes the question, what exactly is the precondition needed? Right? If you ask me what is the precondition needed, precondition for condensation, let me tell you. Right? Precondition for condensation. Right. Two preconditions are needed, my friend, right? For condensation. If you ask me precondition needed for condensation, right? Normally, as I said, two preconditions is needed. What are they? Number one, air mass should be saturated. Now, I am using this word, at least saturated air mass. Right? Where relative humidity, right? I should use this word, what is what? At least. At least saturated air mass. When I say air mass is at least saturated air mass, what is the meaning, my friend? Meaning relative humidity should be more than or equal to 100%. That's what I call them as what at least saturated air mass. So this is the condition where you can have saturated air mass or supersaturated air mass. Okay. Along with this, my friend, very important, hygroscopic nuclei, right? Hygroscopic nuclei, my friend. What is this hygroscopic nuclei? It is nothing but water. Water-seeking solids, right? Hygroscopic nuclei is nothing but what? Water-seeking solids, my friend. Okay. So what is the precondition needed for this condensation to take place, my friend? Two preconditions, right? You should have air mass should be at least saturated, and you should have some hygroscopic nuclei. See, what is this hygroscopic nuclei? I tell you. Example of, if you ask me that example of hygroscopic nuclei, example of hygroscopic nuclei, right? Anything, my friend. Let me write it as example itself, right? Example of hygroscopic nuclei, my friend. Any solids, all right? It can be any aerosols, right? The dust, aerosol itself is an umbrella term. It can be a dust. Am I right? It can be a pollen grain. It can be volcanic ash. It can be particulate matter, right? It can be anything, my friend. Fine particles of sand particles, right? Sand particles, right? Even as last class, we talked about harmattan. Harmattan resulting in what? A welcome precipitation. How it is possible? Hygroscopic nuclei. Am I right? My friends, you would have heard about this cloud seeding as a concept, right? What exactly they do in cloud seeding, my friend? They add more hygroscopic nuclei to the saturated air mass. So by the time, once the air mass is saturated, if hygroscopic nuclei supply is there, what happens? This water will start, say for example, start its condensation process around this hygroscopic nuclei. Okay. So this water-seeking solid is also very important for condensation, my friend. So what is condensation? We have an idea. Now, when we talk about condensation, my friend, condensation happens at different places at different levels, right? Now, in that regard, if you ask me condensation, where all condensation will take place, my friend, condensation will take place on the ground. You call them as what? On-ground condensation. Condensation will right? Condensation can also take place high in atmosphere. We call them as what? Atmospheric condensation. Right? You call them as what? Atmospheric condensation, right? Condensation takes place on the ground, near the ground, and high in the atmosphere. See, the condensation which takes place on the ground, my friend, right, depending on the state of matter, either you call them as dew, right, or you call them as what? Frost, my friend. What is dew? Dew is nothing but what? Water droplet. Water droplet, you call them as what? Dew. Then what is frost? Frost is nothing but what? Ice crystals, my friend. Right? This ice crystal, you call them as what? Frost. Okay. Right. What is dew? What is frost? We have an idea. It is on-ground condensation. Normally during the winter nights, my friend, morning walk, you go for a morning walk during the winter times, right? You'll be finding small water droplets, right, which is, say, for example, which is there in the leaf of the plants, even the parked vehicles, bike, car, everything. Am I right? You'll be finding these water droplets. That's what you call them as dew. You're there and say, for example, you go to a place where you experience a sub-zero conditions, my friend. Even Ooty, Kodaikanal and other hill stations you go, say, for example, during the peak winters, my friend, peak winters, there you'll be having small ice crystals which is formed over the leaf of the plant. That's what you call them as what? Frost. And my dear friends, when we talk about near ground condensation, right? Either this near ground condensation can be an example of a fog, right? Or sometimes it can be an example of what? Mist. See, fog and mist, technically, yes, there is a difference. I accept. Right? But normally, let me tell you, in general studies preparation, assume that fog is a dense cloud. See, cloud all the way descending and coming to the surface, that's what you call them as fog. High intensity, where the visibility is less, you call them as fog. Low intensity, where the visibility is more, you call them as what? Mist. Right? And my dear friends, and finally, if you just ask me, right, then what exactly is atmospheric condensation is called as? This atmospheric condensation is very popularly called as cloud. The most commonest form of condensation is what? Cloud. So my dear friends, only thing is that we have to discuss about this different forms of condensation. Dew and frost, that is on-ground condensation. Condensation taking place on the surface itself. Number two, near-ground condensation, where the condensation is taking place near the surface or the pre-condensed form is coming near the surface, fog and mist. And finally, the atmospheric condensation called as cloud, which is the most commonest type of condensation. And we'll be talking about different types of cloud. Based on shape, you can classify them as what? Cumulus clouds, stratus cloud, and right, and cirrus cloud. Based on height, you can call them as what? Low altitudinal cloud, mid altitudinal cloud, and high altitudinal. Right? And again, based on the weather effectivity, I call them as what? Fair weather cloud, rain bearing cloud, and right, bad weather cloud. This bad weather cloud is very popularly called as what? Nimbus clouds. All the clouds put together, right? To be very precise, cumulus, cirrus, stratus, along with the nimbus, if I'm just combining and going for a combination, I'll be having 10 different types of white difference. This is what we are going to discuss. So what we'll do, we'll take a break, right? We'll come back at 2 o'clock, right? 2 o'clock, and we'll be discussing the rest of the topics. The complete hydrological cycle we can complete. Right, my friends. So we'll just take a break and we'll come back at 2. Thank you.